let's get this going. All right. So our property, oh, come on now. All right, we're back. So the addition property of equality. So this is all stuff that we use on a normal basis when we actually solve equations. So basically what we're saying is if you have an equation, if you have something equal to something else, we'll just say A equals B. A and B could be any number as long as they're the same number. The addition property of equality says that if we add the same thing to both sides, then the equation stays the same. So that would be like A plus C equals B plus C. These are the rules that we use when we solve equations, right? We can add the same thing to both sides and the equation stays the same. The subtraction property of equality, same idea. If you have two numbers that are equal to each other, that means it's really the same number. If you take those numbers and you subtract the same number from each of them, then the equation stays the same. So for example, on this first one, if A and B are each 14 and C equals 2, you'd have 14 here and 14 here. Then you'd have 14 plus 2 here and 14 plus 2 here, which means both sides would still be equal because now they'd be 16, right? So it's just like solving an equation. The next one is, let's see, if A equals B, then if you multiply them, A times C would equal B times C, as long as you multiply them both by the same number. These are basic algebra rules that we learned, that you all learned probably way back in pre-algebra or maybe even before that. Division property of equality says if you've got two numbers and they're the same, if you divide them both by the same number, then it still equals the same thing on both sides of the equation. All right, the next one is the distributive property. And it says if A times B plus C, if you have A times B plus C, then if you take your original left side of the equation and you distribute A to both B and C, remember with distributive, you just multiply everything inside the parentheses by the thing on the outside. You end up with A times B plus A times C. So this stuff here equals that there. That's the distributive property. If we put numbers in, they'd end up being all the same on both sides there. All right. What we got so far. The next one is the substitution property. That's when you plug something in for something else. We've been using that a lot, actually. In terms of finding a value of X and then plugging it back into an expression. We've been doing that a whole bunch over these first few weeks. And so the substitution property says, if A equals B, then A may be substituted by B in any expression or equation. So if you know the value of a number, I'll just write something down real quick. You don't need to write this down, but we'll see examples of it anyway. So like if X equals 2, and you've got like 2X plus 17, you could substitute. So here's our A equals B right here. X is 2, plug it in for X, 2 times 2 is 4, 17 plus 4 is 21. So you're allowed to substitute that in whenever those two things are the same. We use that a lot. All right, don't worry about writing that down. Okay, the reflexive property says for any real number A, or any, for your purposes here, any number, there are other things other than real numbers. If you take Algebra 2, you'll learn about it then. But for this year, every number that we work with is a real number. For any real number A, here's maybe the most obvious statement you've ever seen. A equals A. a number is the same as itself. You, that one does get used on occasion. Hopefully we come across an example where we do use it, and I'll tell you why if we do. The next one, the symmetric property. This one is also pretty obvious, but it tends to be, I think, a little more useful than the reflexive property. It says if A equals B, then B equals A. So the reflexive property is the same letter twice. The symmetric property is the same two letters, but they're in opposite order. So like if you have an equation, and again, you don't need to write this down, but if you have an equation that says like 4x minus 17 equals 6x plus 2, the left side here, that would be the same as A. This over here is B. They're equal to each other. What we're saying here is we can take this side of the equation and move it over here, and take this side of the equation and move it over here. It's all the same. So we could write 6x plus 2 equals 4x minus 17. So either way, with an equation, both sides are always the same, so you can just flip an entire equation around if you want. Sometimes it can feel useful, sometimes maybe not, but it is something you're always allowed to do, because if it's equal, then it doesn't matter what's on each side. That's what the symmetric property says. All right. Another one here we've got is the transitive property, which is similar to using substitution, but not quite the same. So this one says, if you have one number and it's equal to a second number, and if that second number is equal to a third number, what would then have to be true about A and C? They're the same as well, yeah. So the conclusion here is that if the first is equal to the second and the second is equal to the third, then the first is equal to the third. So A equals C. So if this equals 5 and that equals 5, and this is 5 and that's 5, then these two things are also both 5, so they equal each other. That's the kind of logic we're using for that. Okay, that's how we're setting things up today. Now we're going to get into the idea of what a proof is. And so this unit is all about proving things. And we're going to be using the concept of what's called a two-column proof. And we're going to get used to the idea of that by using algebra. And then once we get used to using algebra, we're going to start using the geometry stuff that we've learned recently. So properties of equality can be used to justify steps in solving an equation. This is just like when we're solving an equation, I'm like, hey, what do we have to do next? And somebody tells me what we do next. And I'm like, okay, why did we do that? And then so the reason for why we're doing something is going to be one of these right here. So like, if there's a step in an equation and you have to add the same thing to both sides, the reason for doing that would be the addition property of equality. If you have to solve something and the last step is to divide both sides by the same number, that would be the division property of equality, the reason why you did that thing. So all you're going to be doing is solving an equation and then saying which property you used on each step to solve. So here we go. Properties of equality. All right, so this is our new stuff for today. It's a two-column proof. It is a common format used to organize a proof. It's basically creating an airtight argument as to why you can get from the beginning of an equation to the end and get the correct answer. And you got this step-by-step process that says, okay, this is what we did. This is why we did it. All right. So now let's see. We've got the left side, and this is the list of, what do they call that? Yeah, okay, statements, yeah. List of statements. So anytime we're working on a two-column proof, we have our statements on the left, what we are doing. So a statement is what you are doing. And the right side is going to be what we are calling the reasons. What did you do on the left? And then why did you do it on the right? So go ahead and get that written down. What did you do on the left? Why did you do it on the right? All right. Different things that you can use as reasons. Today, we are pretty much just going to be using these right here. And these are properties. So one of the things that you can use as a reason would be properties. For today, that's pretty much all we're going to be using. All right, Serenity, why don't you bring that up and charge it? Thanks. Yeah.
No, come away.
But no, but I already gave you your options, a couple weeks ago. So it's that or it's the office. So one or the other. Just bring it up. Get it at the end of class. You'll be fine. Okay. So we got our properties. That's one thing that's what we're gonna be using today. Another thing that we can use are definitions. We have an entire dictionary of terms for Unit 1. Entire dictionary of terms for Unit 1. A lot of those things will be reasons as to why we do things. So all those dictionary terms that you were basically tested on yesterday to match up the definition with the term, those are we're gonna keep using those. Those are not going away. That was not like a Unit 1 thing only. All that stuff we learned about, like vertical angles and adjacent angles and all that kind of stuff with segments, that will continue to happen, and we will continue to use those. So keep your dictionary. Don't get rid of that. The other thing that you can use are these things called theorems. Theorems. Theorems are statements about anything mathematical that is true, and they were proved to be true at some point. We haven't really learned any of them yet. I'll tell you more about them once we see those. And then the other last thing that we will use sometimes are these things called postulates. The statements between theorems and postulates look very similar, but postulates are things that never had to be proved because they're generally speaking pretty obvious statements. And so there's no need to prove a postulate, whereas a theorem is more of an idea about, hey, I think this thing is true, and at some point somebody proved that it was true. So in terms of how they look and in terms of how they're written, basically the same thing. In terms of whether it was proved or not proved, that's kind of the difference between them. All right. Well, what? Where? Right here? No. P-O-S-T-U. Yeah, that's a U. Sorry, the tail on the U is a little bit separated from the rest of it. Okay, so problem number 1, right here at the bottom, it says, so we have our equation, and it even tells us what the answer is. It says that x equals 7. What we have to do is, and by the way, the statements are already here, so we don't have to write down the statements. We just have to say what happened from here to here, using one of our properties. So to get from 4x minus 1 equals 27 down to 4x equals 28, what happened? Yeah, we added 1 to both sides, right? Plus 1 plus 1. 1 cancels here, 27 plus 1 is 28. Which property was that? Yeah. If we add the same thing to both sides, which is what happened here, 1 was added to both sides, that's the addition property of equality. So that's what we're going to write in for step number 2. I'll talk about step number 1 here in just a second. But this would be the addition property of equality. And when you're doing this, you don't have to write out the words addition property of equality. For addition, you can use the plus sign. And then I usually abbreviate property as prop. And then of. And then I'm just going to put an equal sign for equality. So that means addition property of equality. That way you don't have to write out all the words every single time. It'll get really annoying to have to do that. All right, now, step number 1, and the reason here it says is given. That's because step number 1, you always start with the problem that you are given. The reason why we have this problem is because it was given to us. So given will always be the first step in a proof, because you'll have information that you are provided with, information that you are given. And that first reason is, well, it was given to me, so there it is. I didn't come up with it by myself. That's what it is. All right. So step 2, add 1 to both sides, get 4x equals 28, and then from here to here, what happens? There you go. So that's it. This is the idea of a proof. And in starting off here, hopefully this felt pretty simple, right? You just figure out what to do and then you find the property that lines up with it and you write it in. That's basically what we're doing today. It's not going to get much more challenging than what we just did. It'll get longer in terms of the problems that we're doing, but in terms of difficulty, not so much. However, Monday, like I said, once we start applying it to the geometry concepts, it'll become a little more challenging. Yeah. What's that? The point of this is to understand not how to solve an equation. You know how to do that. It's also not to even understand the properties of equality, because this is stuff that you saw in Algebra 1 and probably pre-algebra as well. The reason for this is so you can understand what a two-column group looks like and the structure of it. Because we're going to apply this same structure to geometry proofs starting on Monday. And if you have that structure, it'll make it a little bit, you'll have a basis of knowledge to begin with, as opposed to just starting with geometry proofs right away. So today, like I said, today will probably feel a little bit simple, but you know what? That's probably a nice feeling for a lot of us based on the test we took yesterday. So yeah. There's an assignment, yeah. We'll try to be quick with these notes though, and get you some time to work on the assignment in class. So here we go. Problem number 2, let's see. Here's our given statement. That's the problem we're starting with. So between step 1 and step 2, somebody other than Raf, what happened, Mabel? Yeah, we subtracted 2 from both sides. The 2 went away. It was a +2, which means it was subtracted from both sides. So that'll be the subtraction property of equality. By the way, I do want you to write property of equality and not just property, because with algebra, we have properties of equality. However, a lot of times with geometry stuff, we have properties of congruence, which are a little bit different than properties of equality. So make sure if you have a property of equality, make sure you write of and then equals. Once we get to Monday, we'll see properties of congruence, which we'll use the congruent symbol here instead of the equal symbol. All right, and then the last one, somebody else, what do we have? What happened to get from here to here? Multiplication, yeah. So -6 was multiplied on by both sides. So this would be the multiplication property of equality. Or if you want to use the dot for multiplication, that's fine too. Cool. And if you're ever a little bit unsure of which property is being used, you can check the front page and see which one of those properties seems to match with what happened on the problem. Example 3. There it is. In stereo. Now, the distributive property, just real quick, did not say the distributive property of equality. So we don't have to write of equals on that one. We can just write distributive property. And I'm going to abbreviate distributive as dist. Distributive property. Let's keep going here. This would be the subtraction property, right, of equality. And then the last one. Ralph, be quiet. Catherine. That, yeah. What's it? Oh, because if you look at what happened from here to here, the parentheses went away, which means that the -9 multiplied by the 2 to get -18, and the -9 multiplied by -3 to get +27. Yep. And then the final one, division property of equality. All right. Oh, okay. Here's a next one that has a little bit more to it on this one. Take a look at step number 1. From step 1 to step 2, what does it look like? Subtraction? Do we agree with that? What did we subtract from both sides? That's what we ended up with. What did we subtract though? 6x. Yeah, we subtracted 6x from both sides. So there's our subtraction property of equality. All right. The next one, what happened? Yeah, 17 was added to both sides. So that would be the addition property of equality. And then the next one is the division property of equality. So we're solved for once we get to step 4. However, it does not say to prove that 12 equals x. It says to prove that x equals 12. We gotta flip it all around, right? And the one that flips it all around is the symmetric property. Okay, there we go. So, and again, if you don't remember the words for it, go find it. And then write it in once you find it. So definitely use this list of properties. If you forget what a property is, go back to it. I don't know, it's kind of like putting together, this to me feels a lot like puzzle-like, you know, like which piece fits with this particular step. So we got symmetric property. I usually abbreviate that SYMM. All right. Let's keep going here. First one is going to be, looks like distributive property again. So distributive property. Oh, there's an interesting one. What happened between 2 and 3? Yeah, that's exactly what happened. We combined like terms. That was not a property. It's not a property of equality because we're not doing something to both sides of the equation. When you combine like terms, you just put together two things on the same side of the equation. -7 plus 4 is -3. So sometimes we don't actually have a name for what we do other than what we're actually doing, which is combining like terms. So write that down. Combine like terms. And again, I'm going to do a lot of abbreviating here because it takes less time to abbreviate a word than it does to write the whole thing out. So not every single thing is always going to be like a property or something like that. Sometimes it's just like math, right? We added a couple of terms together by combining the like terms, so combine like terms. The next step there looks to me like we use the subtraction property of equality. Does that sound okay? Subtracted 12x from both sides because the 12x is gone from here to here on the right side, which means we took that away. -3 minus 12 is -15. So that's the subtraction property of equality. Then 14 was added to both sides after that. So that would be the addition property of equality. And then both sides were divided by -15. So division property of equality. Okay, how are we feeling so far? Not great? Okay, yeah, no. Vicky, do you have any questions? When you see the words over here, does it make sense what happened? Okay, so like sometimes it can also help to actually do the work. So like if you wanted to get from here to here without looking over here, you'd probably distribute the -7. You'd probably distribute the 6. And if you distribute from here to here, it's got to go. And then next, if we're going to solve for x, we have to combine our like terms first. And so if you put those together, we combine like terms, so it's got it. And then we just try to figure out, okay, what's different here? Well, the 12x was here, it's no longer here. It was a +12, so that means it must have been subtracted. So that's going to be subtraction. The -14 was here, and -14 is no longer there. To get rid of a -14, we had to add it to both sides, so that means we had to add it. So does that help a little bit? Okay. All right, let's flip this over. Now, you have to do the whole thing on your own. Yeah. Not necessarily. No. If you can solve it in fewer boxes than what's there, that's fine. However, you have to start with this, and you have to start with given over here. So here's the thing with proofs, everybody. Even with today, even with moving forward in this unit, everybody should always be able to get step number 1. Whatever information you are provided with here will always be statement number 1, and reason number 1 will always be given, no matter what. So here we go. Statement number 1, 3x plus 1 equals -14. Reason number 1, given. And when you have to do the whole thing by yourself, it might not even be worth it to look at what you're trying to prove because you're just solving for x, right? So what would our next step be to get from 3x plus 1 equals -14 to the next step of the process? You'd have to subtract 1, exactly. If you want to show the -1, like a little -1 here and here, that can make it a little bit easier to get your statement or your reason for the next one, because that -1 and that +1 would cancel. And so we're going to end up with 3x equals -15. And that's the subtraction property of equality right there. Yeah, we're not actually going to use all 4 boxes here. You don't have to use everything that it tells you, or that it gives you in the first place, because all we have to do now is divide both sides by 3, and x would equal -5, which is what we were trying to prove in the first place. Once you have this right here on your statement, you're done with your statements. Just give the reason, and this reason would be the division property of equality. So we're done with that one. We didn't use all 4 boxes, just 3 steps. All right, let's keep going here. Yeah, we'll be able to get through this pretty quickly, I think. All right, next one, problem number 2. Actually, no, I don't want to do number 2. That one's distributed property, addition property of equality, division property. Don't worry about that one. Let's look at number 3 then. We'll do 3 and 4. Then we'll take a look at some of the ones on the back. So here we go. Statement number 1, write the problem down. M divided by -3 plus 10 equals -1. That is given. All right. Add, or wait, what are we gonna do? Yeah, let's subtract 10 from both sides. So 2, we have subtracted 10 from both sides, so -10, -10. You can show this step here or not, it's up to you. So that'll give us m divided by -3 equals -11. We subtracted 10 from both sides, therefore step 2 is the subtraction property of equality. And this is another situation where we're not going to use all 4 boxes because we only have one more step to solve. What is it? Other one. It's already being divided, so we want to undo the division by multiplication. There you go. Multiply both sides by -3. -3's will cancel there. We got m equals 33, which is exactly what it told us to do. It's make m equal 33. We've done that. And the final thing we did in order to make that happen is we undid the division by multiplying. So 3, multiplication property of equality. All right. I'm going to pause here for a second. Anybody have any questions? I'm moving quickly because I trust that all of you know how to solve equations. If you're still having a little bit of trouble solving equations in the first place, please stop by for TAT so we can work on that while we're doing this. If you're confused about which properties to use, also let me know. That'll be a good thing to ask about if you're unsure. I don't see any hands up, so let's keep going then. Number 4. This one, we're going to use all the boxes. So start by writing in the problem. That's 5y minus 1 over 2 equals 7. That's given. Now, because the entire thing is being divided by 2, what do we have to do first? Multiply by 2. We got to get rid of the denominator first. By the way, this is almost exactly like those problems that we had where you were given an endpoint and a midpoint, and you had to find the other midpoint. This is very similar to that kind of a question. So if you multiply both sides by 2, statement number 2 will say 5y minus 1 equals 14. And that was the multiplication property of equality. What's next? Addition. Yep, add 1 to both sides, plus 1 plus 1. Statement number 3 then will be 5y equals 14 plus 1, which is 15. And reason number 3, addition property of equality. Divide. There you go. So statement number 4, y equals 3 because we divided. So statement or reason number 4, division property of equality. Piece of cake-ish, right? All right. I'm going to pick only one more from this page. And let's see. Let's do number 8. Yeah. Let's do the tough one, because you probably see something like that on your assignment. So let's go ahead and pick the tough one here. All right, statement number 1, write the problem down. 14 minus 2 times x plus 8 equals 5x minus 3x minus 34 in parentheses. Why? Because it's given. If you have parentheses in an equation, first thing to do would probably be get rid of those parentheses. What allows us to get rid of parentheses? The distributive property. So reason number 2. Reason number 2 is the distributive property. We haven't even done it yet, but we know we have to get rid of the parentheses. So over here, we're going to take our -2. Make sure you use the negative when you multiply here. And then on the other one, you also have to distribute the negative, which is like a -1. That's what we're doing. So statement number 2 will be 14 minus 2x minus 16 equals 5x minus 3x plus 34. Yeah. What's that? It was already there. Oh, you have to multiply. So, Vicky, you can only multiply by the thing that's directly next to the parentheses, which is the negative here. So the 5 isn't right up against the parentheses, the negative is. So we're distributing a negative instead of the 5. Yeah. And the negative is just a -1, essentially. So, all right. What's our next step? Combine like terms, yeah. So reason number 3 is combine like terms. We haven't actually done it yet, but we're going to. On the left, the 14 and the -16 will go together. So that'll give us -2x. 14 minus 16 is -2. So -2x minus 2. On the right, the 5x and the 3x will go together. 5 minus 3 is 2. So that'll be 2x plus 34. All right, now that we're on statement number 4, we actually have a couple of options. We have a few options on what we could do. There isn't exactly one right thing to do next. So what is that? Addition? Okay. What do you want to add? 2. Just the 2 here? All right, let's do it. So plus 2, plus 2. Great. So we'll add 2 to both sides. And that will give us -2x equals 2x plus 36. And that was because of the addition property of equality. Some equation solving has a few options here and there. We had the option to do that. We could have done something else and we chose not to. We're going to do something different now. Subtract 2x from both sides. All right, so we got all our regular numbers over here. So let's get all of our variable terms to the left. So if we subtract 2x from both sides, please remember that if you start with a -2 and you subtract 2 more, the answer is not 0. It is -4. Good. -4x equals 36. And on that step, we use the subtraction property of equality. And then we're going to divide. Yeah, you got it. So 6, what does x equal? -9, yeah. And the nice thing is it tells us what the answer is going to be. And all you have to do is verify that that is true. -4 or 36 divided by -4 is equal to -9. And that is the division property of equality. Cool. That's it. So all it is equation solving with saying what we're doing. That's it. All right, let's turn the page. And then we'll fill out this next page here. We'll be pretty quick with it. We got ourselves a list of properties over here, A through I. We're going to fill them out over here. So if k equals 3, then 3 equals k. Which one's that? H. That is a symmetric property. Good. To get from 2x equals 14 to x equals 7, what happened? We divided. I agree. Number 3 is like looking in a mirror. What do you see when you look in a mirror? Your reflection. So that would be the reflexive property. G. That's how I always remember that one. If it's the same thing, the exact same thing on both sides, it's its own reflection, therefore it's reflexive. Number 4. A, yeah. 1 was added to both sides. What do you think about 5? Yeah, it is I. If the first thing is equal to the second thing, 10A equals 2B, and the second thing, 2B, is equal to the third thing, C, then the first thing, 10A, is equal to the third thing, C. So that would be the transitive property I. 6, E, distributive property. All right. How about 7? A again, yeah. Oh, wait, no, it's not. It's not A. We didn't add anything. Number 7? It's what? How are these two different? What's after the 6Y? Subtraction. So which one is it? Subtraction. Yeah, it's B. All right. Number 8. If 10x equals W and W equals 1, then 10x plus 1 equals 41. That is substitution, yeah. This right here, here's the thing about substitution versus transitive. Because this looks a lot like the transitive property, doesn't it? In terms of how it was structured, right? There's 3 different equations. And with transitive up here, there were 3 different equations. It looks really similar. The main difference is this was the same stuff all the way through. First one, second one, third one, first one, third one. The order matters here. With number 8, it's a little different. We've got, if the first one equals the second one, and part of the first one equals a number, then that number got plugged in back to the first one. So the structure is a little bit different, even though we've got like 3 equations. What we're doing with those 3 equations is different. So what happened is this one plugged in for W right there. So that is substitution. So this W went away and was replaced by the number 1 in the first equation. So this W here was swapped out for the value of W here, which is 1. Okay. How about number 9? C. We multiplied on both sides for that one. Okay, how about 10? That's I again. Yeah, that's the transitive property again. So this one is, we got the first thing equal to the second thing equal to the third thing, first thing equal to the third thing. That's transitive. Which one? A for number 11? Yeah. It didn't actually add them together, but it did show the addition. Therefore, we added the same thing on both sides, meaning addition property. All right. 12. H. I heard a couple answers there. Why is it H? So it's the same thing here and here, but the only difference is it's been swapped around. Yeah. So that would be symmetric. So that is H. Thirteen is F. Yeah. And I feel like it's a little bit more obviously F on this one than on number 8 because of the parentheses. I think the parentheses make the substitution a little bit clearer. Like on number 8, had this 1 been inside parentheses like that, I think that would have been a little bit more clearly substitution, because that's something that I teach a lot, is when you substitute something in, it's a good idea to put it in parentheses. And so the fact that it wasn't there maybe made it look like transitive when it wasn't. This one here, parentheses, that's kind of a clue there that if you go from no parentheses to parentheses, you probably substitute it. How about 14? C? Yeah. Multiply both sides by 8. Good. 15. G. All right. And then the last one. B. It is the distributive property, even though it's backwards, right? Even though it went from 5x plus 8x to x times 5 plus 8, it's still the distributive property. It's just kind of working backwards. Technically, it's called factoring, right? But it's still the distributive property. All right, we're almost done here. Oh, wait, we are done here. Great, that's everything. Cool. Let me get your assignment. So you can have like 22-ish minutes. You got over 20 minutes to work today, which is great. There you go. There you go. 4, 5. Okay. So a couple things. Feel free to get started on this. Other stuff, I'm gonna go ahead and say Monday for turning in anything from Unit 1. But after Monday, that's the cutoff date for turning in anything from Unit 1. If you have missing assignments right now from Unit 1, turn those in by Monday. You can still get credit for them. It will be reduced credit, but it will still be credit. Same thing with the unit review. You can turn that in by Monday, but it is an assignment. Rob, question? Yeah. Looks like it to me. Yeah. All right.